Dear students, in our today's session, we are going to discuss about motion in one dimension. And under this chapter, we have three different equations of motion that you might have heard of. So, in this session, we are going to see how we can derive those equations of motions. Okay. So before I go ahead, let me write a few details and let me write these equations for your convenience. So the first equation of motion is like v, that is the final velocity, is equal to u, that is the initial velocity, plus at. Okay, this is the first equation of motion. M is acceleration and t is the time. Fine. Now the next equation of motion is s equals to, where s is actually the distance traveled. Okay, equals to u, that means the initial velocity, and then we have t, ut, plus half at square. Again, the words contain the same meaning, that is that t is the time taken, a is acceleration, u is initial velocity, and s is the displacement. Okay. Now the third equation of motion is v square, that means the square of final velocity, minus u square, that is the square of initial velocity, equals to 2as. Okay, v square minus u square equal to 2as. Again, v square is the square of final velocity, u square is the square of initial velocity, and this s is the displacement, and a is the acceleration. Okay, so now let's see how we can derive these equations one by one. So the first equation, that is, let's say v equal to u plus at. So for this, as we know that by the definition of acceleration, so acceleration is actually what? Like if we go ahead and type for the same, acceleration is nothing but just the change in velocity and time taken for this change to be effective. Okay? Change in velocity upon time taken. Now what is this change in velocity? If we can rewrite the given equation, acceleration equal to, like we can say that final velocity minus initial velocity upon time, right? Now how can we write this equation in terms of symbols? Like here we have, let's say, acceleration, we can define it with a, right? Then final velocity can be defined by v, initial velocity can be defined by u, upon time taken can be defined by t. Now if we can make a cross multiplication, so we can say that this a and to t equals to v minus u. Okay. Or again, if we put this u to the left hand side, we can say that this v is actually equals to u plus at, and this is your first equation of motion. Just a two-line statement, and you can derive the first law of equation, first law of motion, in this manner. Okay. In a similar manner, let us move towards a derivation for the second law of motion. So, according to the second law of motion, it's something like, if you can, as per the definition, if we write it, we can say that this speed is equals to distance upon time, right? Or in other words, we can say that the distance traveled is equal to average velocity into time. Okay, average velocity into time. Now, what is this average velocity? Average velocity equals to initial velocity plus final velocity, right, divided by 2, right? This is how you can calculate the average, that is initial value plus final value upon the 2. So now let us put this same equation in the above said equation actually for a distance, that is distance traveled is equal to like product of these two, that is initial velocity and final velocity. Final velocity multiplied by time, and this whole is divided by 2. Let me extend it a little bit. This is how, right? Let me write it in a symbolical manner that will be more, easy for you to understand. So let's go ahead. This distance traveled is s. Okay. Then in brackets you can write initial velocity as u, final velocity as v, right? Whole is multiplied by time, which is given by t, and this is whole divided by 2, right? Now, as per the first equation of motion, or first law of motion, you know very well that v is always equal to u plus at, right? This is what we have already proved in previous, derivation. So just put this value of v over here, right? So what it will become? This will become s equals to u plus u plus at into t upon 2, isn't it? This is how you can write it. If you put the value of v over here from this first equation of motion, now what will happen? This s can be further written as u plus u, that will become 2u, right, plus at into t upon 2, isn't it? Now just open the bracket, and what you will find? You will find that it will become 2 ut plus at square, isn't it? This will become at square upon 2, right? Then if we further try to divide it, so we can say that this will become s equals to ut plus half at square, right? And what is this? This is what actually your second equation of motion, right? This is how you can derive the second equation of motion as well. Fine. In the similar manner, let's try to find out, the third law of equation as well. And the third law of equation was v square minus u square equal to 2as, right? Now again, if we further try to divide it, so we can say that this will become s equals to ut plus half at square plus 2, isn't it? This will become s equals to ut plus half at square plus 2, right? Then if we further try to divide it, so we can say that this will become s equals to u plus 2 square plus u square equal to 2a, right? Now again, So let's take initial in the same manner, like in the same manner we have done this previous equation, like distance traveled equals to something like v plus u upon 2, that is the average velocity. So average velocity is what? This is v plus u upon 2 into t, isn't it? Now, as per the first law of equation, first law of motion, we have seen that this v equals to u, v equals to u plus at, right? So we can say that this, if we can try to define the time over here, we can say that this should be like v minus u upon a, isn't it? So this, now let's put this value of t, whatever we have achieved over here. We can put this value of t over this way, or like we can put it like as s equals to v plus u upon 2 into v minus u upon a, isn't it? We have just put the value of t from this particular equation. Now we have s equals to, now the formula is v plus u, v minus u, right? Or you can recall this formula from your factorization chapter, that is a plus b, a minus b will be a square minus b square. Okay, so it should be like v square minus u square upon 2a, right? And again, now finally you can make some kind of your cross multiplication, and it will give you v square minus, let me correct it, v square minus u square equals to 2a s, right? And this is what your third equation of motion, all right? So by this way, you can simply go ahead and derive all the three equations of motion, right? And as a part of the physics, it is mandatory for all of you to just memorize all the three equations of motion, right? So let me go ahead and show you further these three equations here. So the first equation of motion is v equal to u plus at. Second is s equals to ut plus half at square. And the last one is v square minus u square equals to 2as. Okay. So under this motion in one dimension, you are all requested to go ahead, try to figure out like how I'm doing this particular derivations on this particular page, and try to note it down in your notebook as well, so that you can understand it in a better way. And till further, if you have any problem, any question, feel free to let me know on that. Okay. Have a nice time ahead and take a very good care of yourself. Bye bye.